In this lecture, we want to learn how to find the line of transmission and the line of centers for two rigid bodies when motion is transmitted between them. We will also try some examples to help understanding these lines in each method of motion transmission. Let's start with this example. In order to find the line of transmission, we need to think of a direction along which the motion is transmitted from the driver link to the follower link. In this example, we have direct contact between the two links. Link number 3 rotates counterclockwise and pushes link number 2 to rotate. In a case of direct contact like this, the line of transmission passes through the contact point and is along the normal direction of the two surfaces being in contact. Something like this, if I can draw it precisely. Now let's think about the line of centers. In this example, each of the two bodies has a center of rotation. Point 02 is the center of rotation of link number 2, and point 03 is the center of rotation for link number 3. So the line of centers is simply the line connecting these centers. Something like this. The intersection of the line of transmission and the line of centers, if we call it point Q, is an important point and has some properties. In the upcoming lectures, we will see how we can use this intersection point to relate the angular velocities of the driver link and the follower link. This helps to estimate how the angular velocity is transmitted between two links. Let's see another example of direct motion transmission. In this linkage, link number 2 rotates clockwise and pushes link 3 to rotate. The motion is transmitted from link 2 to link 3 by means of a pin on a slot joint. As you see, a pin of link 2 is constrained to move along a slot of link 3. In a case of pin on a slot like this, the line of transmission passes through the pin and is perpendicular to the slot. Something like this. Now for the line of centers, we can simply connect the two rotation centers. So the center of follower to the center of driver, and extend the line until it intersects the line of transmission. We usually name the intersection point as Q. In the next example, we have an indirect motion transmission. Let's name the links 1, 2, 3, 4. Link 2 is the driver and rotates clockwise. The motion is transmitted from link 2 to link 4 via this rigid link. In a case of rigid connector like this, the line of transmission is along the rigid link. More precisely, if the rigid link is pinned to the driver and the follower, the line of transmission is the line connecting the two pins. Now the line of centers is the line connecting the centers. Here is the intersection, which we call point Q. In this last example, we have an indirect motion transmission via a flexible belt. We name the links 1, 2, 3, 4. Pulley number 2 rotates counterclockwise and transmits this rotation to pulley number 4 by means of belt number 3. In a case of pulleys and belt like this, the line of transmission is along the belt. Let's extend the belt up to here. Now for the line of centers, we connect the centers of the pulleys and continue to intersect the line of transmission. Let's name the intersection Q as usual.